The cybernetic control loop as information process. The basic control loop. The term cybernetics comes from the Greek word kyberneo, which means to steer, to guide, or to govern. In plain English, it is the theory of control. We are all familiar with the basic control process. You do something, you act. You see how it turns out, you sense. You compare the results to what you wanted, evaluating. You choose another action to bring it closer to your goal. You choose. And then you do something else. You act. These four processes form a loop. Any control process consists of going around this basic control loop. Act, sense, evaluate, choose, act. Each of the individual processes around the control loop is an information process. An information process consists of translating one form of information into another form of information. We can use the box as a symbol of the translation process and the arrow as a symbol of the information. Thus, information input is translated into information output. Acting consists of our action being translated by the environment into results or changes. Sensing consists of the changes being translated by our models into perceptions. Evaluating consists of our perceptions being translated by our values into needs. And choosing consists of our needs being translated by our options into action. The translation processes are themselves information. They are commands about how to process information. In other words, programs. The translation processes constitute the program that controls the control process. Thus, changes are interpreted by models to produce perceptions, which are evaluated by values, which produce needs. The needs are assessed by the options and chosen an action which acts on the environment in order to produce changes. This is a general model of control. It applies to all control processes. To analyze any control system or decision-making system, there are four questions. What part of the environment is the system trying to control? What is the model they're using to understand the environment? What values are they attempting to maintain, and what are the options available to them? The process dualism problem. The primary problem in diagramming a cybernetic system is the problem of attempting to diagram two incommensurate system processes that are operating simultaneously, the energy process and the information process. One solution is to simply diagram the mechanical parts, as in this diagram of governor. Thus, the boiler produces steam, the steam engine drives the drive shaft. The drive shaft is connected to a spindle. The spindle has arms with fly balls on them, so that when the spindle spins, the fly balls are linked to a sleeve, which will go up and down depending on the speed at which the spindle is moving. That sleeve is connected to a lever, which is connected to a valve, which controls the amount of steam that is going into the steam engine. The problem with this diagram is that it is too specific. The two processes are not immediately evident. Another attempt is to do a diagram with functional boxes. We see this with the Norbert diagram. Thus you have a subtractor feeding into a compensator, which feeds into an effector, which produces output. From the output, there is a feedback takeoff that returns back to the subtractor. The arrows indicate that there is a process, but it is unclear what kind of process. The feedback takeoff leads to immense confusion. It is an information process because energy processes do not form loops. But many materialists have assumed that it must be an energy process. Other people have attempted to include both processes. Von Bertalanffy is careful to label some of the arrows as messages. Thus, the connection between the receptor and the control apparatus is a message, and the connection between the control apparatus and the effector is a message. And then there is a response, and the response produces feedback which returns to the receptor. Although this is a diagram of an information process, it does not make it clear that the feedback takeoff is information about the results. The environment is missing. A more successful attempt is the system dynamics model of Forrester. A box has been added to the diagram to indicate the information processes. The information processes are indicated by arrows with dotted lines. The material processes are indicated by an arrow with a solid line. One problem with this model is that the environment is too specific. It describes an inventory system. Using this diagram to describe a governor is very difficult, even though it too is controlling a valve. This diagram has two separate processes instead of two different aspects of a single process. In the following diagram, the governor is diagrammed from these three aspects. Each of the mechanisms is on the center line and indicates a transformation process. On the top line is the information process, divided into 4 steps: sense, evaluate, choose, act. This is Gestalt number 1. On the bottom line are a series of equations that indicate the energy processes, divided into a set of equations. This is Gestalt number 2. The problem with the energy process is that it does not form a loop. It has to connect to a collateral source of energy. The energy from the lever moves the valve setting. The valve setting controls the steam engine. Form controls matter and energy. As a simple model of a cybernetic loop, it is simplest to diagram it as an information process.